The Natal Railway Company bought the Natal in 1860, and that June opened a short line between Durban and the Point, before the completion of the Cape Line. Both of these pioneer locomotives have been preserved. The construction and spread of railway trunk routes throughout South Africa would await the discovery of the rich Kimberley diamond fields in 1869. Both the privately owned Cape and the Natal railways were constructed to the gauge of 4 foot 8.5 inches, 1435 millimeters, the standard used in England. Another private railway with a gauge of 2 foot 6, or 762 millimeters, had already been built in the Northwest Cape to carry copper to the coast. In 1873, the Cape Parliament appointed a select committee to consider a suitable gauge. Their final choice was a compromise between the narrow 2 foot 6 inches of the private copper line and the 4 foot 8.5 inches then in use on the existing main lines. Thus was born the Cape gauge of 3 foot 6, or 1,065 millimeters, which was to become the standard for railway development in the entire South African subcontinent. In 1874, the private railway lines around Cape Town were taken over by the colony under the umbrella of the Cape Government Railways, or CGR. 4 years later, the Natal Railway Company was absorbed by the provincial authorities to form the Natal Government Railways, or the NGR. During the latter part of the century, the railway systems forged further inland, and some other railway administrations and companies were formed. Notable amongst these, as far as locomotive motive power was concerned, was the Transvaal Railway Company, or ZASM. Following the end of the Boer War in 1901, the Orange Free State and Transvaal railway systems were incorporated into the Central South African Railways, or CSAR. The provincial car, the 042 arrangement, built by Hawthorne and Company in 1859. The locomotive had somewhat of an interesting history, having been transferred to the Port Alfred, or Kawe Railway in 1874. It was later mounted in Grahamstown until 1913, when it was transferred back to Cape Town, and now stands in place of honour in the station concourse. In 1860, another 8 042 locomotives, also built by Hawthorne, were imported for the Cape Town to Wellington Railway. These were followed by 3 240 saddle tanks for the line to Wynberg. In Natal, the first locomotive, an 040 tank built in London, was placed in service in 1860. This locomotive was later sold to a farmer at Port St. John's, buried, and finally retrieved and restored in 1943 and 1944. In 1865, another standard gauge engine, a 440 saddle tank, was supplied by Kitson. The Cape Government Railways Class 2, 6262 tank engines, were the first Cape gauge locos to be built by Stevenson & Co. in 1874. Several different types of locomotives followed. They were all later reclassified as Cape Government Railways Obsolete First Class. Class 01440, Obsolete ex-CGR First Class. 17 engines were delivered between 1875 and 1881, 6 by Stevenson's and 11 by Nielsen's. 2 came into SAR stock and were withdrawn by 1913. Class 01260, obsolete ex-CGR First Class by Bayer Peacock and Avonside. 18 locomotives were delivered by these two companies between 1875 and 1877. 3 came into SAR stock, but were withdrawn by 1916. Class 01440, obsolete ex-CGR First Class by Avonside and Nielsen. 14 were ordered between 1879 and 1880 from the two manufacturers. 9 came into SAR stock, but were withdrawn by 1915. Cape Government Railways back-to-back failure locomotives. In 1875 and 1888, experimental 060 plus 060 locomotives were built by Stevenson and Avonside for both Western and Eastern Railways. The 2 of the class were separated for shunting, and the last, the 1888 engine, was scrapped in 1903. CGR 4th Class Stevenson 460. 92 locomotives were built by Robert Stevenson & Co., as well as Nielsen and Company between 1878 and 1884. When originally delivered, they had Joyce valve gear and side tanks. They were normally fitted with tenders as well. Some were used as standard tank locomotives. CGR 4th class converted Joyce 460. The 4th class Stephenson locomotives were extensively modified during service. Side tanks were removed and the Joyce valve gear replaced with Stephensons on a number. In their various forms, 32 were taken into SAR stock. They were withdrawn by 1932. CGR 5th class Dubs 460. 50 locomotives were built by Dubs between 1890 and 1891. CGR 1st class Baldwin 260. CGR 4th class Atlantic 442. 6 locomotives were built by Baldwin in 1897. CGR 3rd class Weinberg Tender 440. Sharp Stewart and Company built 14 locomotives of this class in 2 batches, which differed slightly, in 1901 and 1903. All but 1 were taken into SAR stock. CGR Class Experimental 2 and Experimental 3 280s. Class Experimental 4 282. 2 locomotives were built by Kitson and Company in 1903 as an improved version of the 8th class with a wider firebox for improved steaming. Kitson Mayer 060 plus 060. The CGR Kitson Mayer lasted until 1911, but was not allocated an SAR class or number. Class Experimental 5 282. During 1906, an enlarged version of the Experimental 4 was delivered from Kitson. CGR Experimental Class 1 462. This single 462 was delivered in 1906 by the North British Locomotive Company. Other railways came and went during the provincial period, like the Metropolitan and Suburban Line. The Currie Railway, linking Grahamstown and Port Alfred in the Eastern Cape, acquired these 2 060 tanks from Hunslet Engine Company in 1882, and 2 440 tanks for passenger work, also from Hunslet in the same year. Natal Government Railways, NGR. NGR Bayer Peacock 260 tanks. 2 of these locomotives were ordered from Bayer Peacock in 1876 for construction work and were the first on the new Cape Gauge system. A single 282 tank locomotive, the first to have 8 coupled wheels in South Africa, was built in Durban in 1888 and was named Havelock after the governor of Natal. It was later converted to a 462 and ultimately scrapped in 1905. For the Zululand Railway extension north of the Tugela River, 1 262 tank and 2 260 tender locomotives were built by Baldwin in 1901. These locomotives were eventually absorbed into the NGR stock, but were scrapped later prior to service on the SAR. De Nederlandse Zuid-Afrikaanse Spoorwegmaatschappij, more popularly known as the ZASM. 2 040 tank locomotives were built by Emil Kessler in Germany in 1889 for the newly completed first railway of the Transvaal, or ZASM, between Johannesburg and Boksburg. ZASM 19-tonner 042 tank. 24 locomotives were delivered to the ZASM by Emil Kessler and Bakker and Reib between 1890 and 1892. A further 5 060 tank locomotives, known as the 18-tonners, were put into service in 1890. 2 orders of a total of 20 tank locomotives, known as 40-tonners, of the 062 arrangement were ordered by the ZASM from Emil Kessler between 1891 and 1893. ZASM 042 rack tanks. 4 042 tank rack locomotives were delivered to the ZASM between 1894 and 1897 by Emil Kessler. The Pretoria-Petersburg Railway, 060 tanks. The Central South African Railways, CSAR. After the Second Boer War in 1902, all the railways of the Orange Free State and the Transvaal were amalgamated as the Central South African Railway System. CSAR Class 9 462. 5 Pacifics were delivered in 1904 by the Vulcan Foundry to the designer P.A. Hyde. CSAR 464 rack tanks. 2 464 rack tank engines were built in 1905 by the Vulcan Foundry for use on the Waterval-Onder, Waterval-Boven section. A number of interesting and varied steam locomotives appeared in service on the major provincial harbour systems, mainly for the purpose of construction. These 3 040 tanks were built by Hunslet Taylor between 1874 and 1884 for the Port Elizabeth Harbour Board, and are hence believed to be the first 346 gauge locomotives in service in South Africa. 10 locomotives were delivered as 260 tender engines in 1875, then converted to saddle tanks. A diminutive 040 tank built by Ruston Proctor and Company in 1881 saw service in the Cape Government Railways. 15 040 saddle tanks were built by Black Hawthorne and Company between 1889 and 1898 for use on the Table Bay and Port Elizabeth Harbour Boards. 11 260 saddle tank locomotives were built by Hunslet in 1904 for the Table Bay Harbour Board. East London Harbour Board 060 saddle tanks. 2 engines were supplied in 1902 by Hunslet and passed into SAR service as numbers 1027 and 1028. Natal Government Railways Hunslet 060 tank John Milne. Built by Hunslet in 1879 as the first locomotive for the Natal Harbour Board, she retained the name John Milne while on the SAR. Natal Harbour Board 040 saddle tank. This locomotive was built by Nielsen's in 1892 and was named Dick King. A Hudswell Clark 060 tank was obtained in 1901 for the Natal Harbour Board. Another tank locomotive, an 040 saddle tank, was obtained from Hudswell Clark in 1902, and this was named Congella. 2 further 060 saddle tanks were built in 1901 by Hudswell and 1904 by Hunslet for the Natal Harbour Board. This 040 tank is one of 2 built in 1901 and 1904 by Hudswell and Hunslet respectively for the Natal Harbour Board. The 14-ton Emil Kessler was restored for service during the Rand Tram Centenary in 1990 after having spent many years on the Johannesburg Station concourse. It now resides in the New Railway Museum at George. After union in 1910, all the various provincial systems were incorporated into the newly formed South African Railways, or SAR. Most classes of locomotives taken into service at the time were reclassified to the SAR standard system. In 1922, the SAR took over the operation of the former colonial narrow gauge system in Southwest Africa. Gradually, this system was converted over the years to Cape gauge. In 1981, the Railways and Transport System became known as South Africa Transport Services, or SATS. In 1990, all the segments of the parastatal transport organization were again regrouped, this time under the name of Transnet, and the railway part itself fell under the name Spoornet. SAR tank locomotives. Class A 482 tank. The first locomotive of this wheel arrangement in use in the world was introduced by the Natal Government Railways. 100 of these tank locomotives were built by Dubs and Company during 1888 and 1889. Class B 064 side tanks. These locomotives were the mainstay power of the ZASM. Between 1882 and 1898, 175 were delivered by M.O. Kessler and 20 more in 1899 by the Netherlands Locomotive Factory. They were known otherwise as the 46-tonners. 55 were taken into SAR stock, all of which were withdrawn by 1930. They had outside plate frames, Walschutz valve gear, and used saturated steam. 3 Class Bs are preserved, 2 in working order. This one, belonging to the Transnet Heritage Foundation Museum, or THF, is now based at the George Museum. Class C 460 tank. Between 1879 and 1884, 37 Class C tank engines were ordered from Kitson and Company and Robert Stevenson and Company for the Natal Government Railways. Some of these 29-ton locomotives were fitted with small four-wheeled tenders which increased their fuel carrying capacity when required to work long distances. One of these locomotives, XASR number 62, was declared a national monument in 1983. It is now on permanent loan to the San Razum Preservation Group in Krugersdorp from Eskom and is the oldest operating locomotive today in South Africa. Class C1 462 tank. One of the Class C tanks was rebuilt to a 462 type in 1901. It became Class C1 number 77 on the SAR. In 1912, a further 4 locomotives of this type were built. They were all withdrawn by 1931. Class C2 464 tank. In 1896, one of the 460 tank Class C locomotives was converted into a 464 tank for service on the Natal South Coast. Class D 264 tank. 6 of these 55-ton locomotives were ordered from Bayer Peacock and Company in 1897 by the Pretoria-Petersburg Railway. Class E 464 tank. The 10 locomotives of this type were built by Nielsen Reed and Company in 1904 for the Natal Government Railways. Class F 464 tank. These locomotives designed for the CSAR have already been featured. They were designed for passenger work on the reef and were taken out of service in 1931. Class G 482 tank. This class was designed by D.A. Hendry. Class H 410-2 tank. Increased power requirements led G.W. Reed, the locomotive superintendent of the NGR, to design a tank engine with the 410-2 wheel arrangement. Class H2 482 tank. This class was used for shunting until 1977 in the Durban area. Class J 464 tank. Class K 464 tank. Now we move on to the tender classes of the South African Railways, ranging from classes 1 to class 26. Class 1 and 1A 480s. 50 of these engines were delivered by North British Locomotive in 1904 and 1905. These 107-ton locomotives had plate frames, Valshut's valve gear, but used saturated steam. On the SAR, they became Class 1. 21 more locomotives of this type were ordered from North British and delivered in 1910. The boilers of these engines were lifted, and they were fitted with Hendry's steam reverser. This batch became SAR Class 1A. These locomotives had a combined weight, with the tender, of 110 tons in working order. They were used on services between Durban and Pietermaritzburg, but they also saw service in Cape Town, Port Elizabeth, East London and the Transvaal. They were all withdrawn by 1975, but some entered industrial service, such as these two at Greenside Colliery. Recently they have been retired and passed into preservation stock. Class 1B 482. In 1906, 6 of the Class 1 locomotives had a rear trailing truck added to give smoother operation, thus converting them from a 480 to a 482. These were the first 482 tender locomotives in the world. The converted locomotives became SAR Class 1B. In later years, the trailing trucks were removed and the engines were reclassified Class 1. The Class 2 462s. 2 locomotives were designed by D.A. Hendry for passenger traffic on the NGR main line. 2 more locomotives were built in 1910 by the Natal Government Railways in the Durban workshops, similar to the Class 2 but had Valshut's valve gear and a more enclosed cab. Class 3 482. 30 locomotives were built by the North British Loco Company in 1909 and 1910. The American Locomotive Company supplied a single experimental machine. This loco became SAR Class 3A and was withdrawn in 1935. 10 locomotives, which were superheated and had piston valves, were supplied by North British Locomotive in 1912 and became Class 3B. When they were reboilered with the number 2 boiler, they became Class 3BR. They were later used for shunting and were withdrawn in 1974. Several of these 124-ton locomotives found their way into industrial service, and one is seen here on the Volcom gold mines in the 1980s. Some of these locomotives have now passed into preservation. The Class 4 482s. The Class 4 was a Cape Government Railways loco built by the North British Engine Company in 1911. These engines became known as Class 4A on the SAR. When fitted with the standard number 2 boiler, they became Class 4AR. These 128-ton locomotives were withdrawn from shunting operations on the West Reef in 1974. The Class 5 462s. Designed by H.M. Beattie of the Cape Government Railways for hauling passenger trains between Beaufort West and De Haar, this series of classes were collectively known as the Karoos. The first two locomotives were delivered by Kitson & Co. in 1903 and became SAR Class 5A. They had bar frames, Stephenson's link motion, and used saturated steam. These 117-ton locomotives were withdrawn from service by 1940. In 1904, a further 4 engines were built, this time by Bear Peacock, and became Class 5B on the SAR. When new boilers for some of this class were required, they were given the standard number 1 boiler and became the Class 5BR. Now we move on to the Class 6 family of 460s. Originally designed for fast passenger service on the Cape Government Railways, successive orders for the 6s were placed with both British and American builders between 1893 and 1904 for use on the Cape Government Railways and the Orange Free State systems. The first order for 40 engines was delivered from Dubbs & Company in 1893 and became SAR Class 6. They were an enlargement of the Cape Government Railways Class 5, or SAR Class 05, and weighed in at 68 tons. A further order for 50 locomotives was received from Dubbs & Company and Sharp Stewart & Company between 1895 and 1897. These heavier engines at 75 tons had larger boilers in the first order and were classed 6A on the SAR. 3 6As are currently preserved in working order. A third order was placed with Nielsen Reed & Company for 54 engines, which were delivered between 1897 and 1898. Class 6B on the SAR, they were provided with an 8-wheel bogie tender and weighed in at 80 tons. 33 engines delivered by Nielsen Reed & Company in 1898 were again similar to the predecessors, but were fitted with 6-wheel tenders and became Class 6D. The last 21 plate-frame 6-class locomotives built for the Cape Government Railways were supplied by Nielsen Reed & Company in 1901. Under the CSR administration, several Class 6s were fitted with a larger Belpaire boiler and a bigger cab. The SAR rebuilt many of the Classes 6A and 6B thus. Many of the Class 6s were rebuilt with round-top firebox spoilers in the 1930s, but the large cabs were retained. The next 2 orders were placed with American companies. In 1901, 8 Class 6Gs were supplied by the American Locomotive Company, which lasted until 1961. The 6K was very similar to the Class 6G, but was built by Baldwin. These Baldwin locomotives were withdrawn in 1928. The Class 6J locomotives comprised 14 machines which were supplied in 1902 by Nielsen Reed & Company, used initially on the Cape Main Line. The last engine of this type was withdrawn from service in 1972. The Transnet Heritage Foundation has 1 locomotive preserved in working order at the George Museum. 2 engines were delivered by Nielsen Reed & Company in 1904, and these became the SAR Class 6L. They were initially fitted with smokebox superheaters, which were not successful, and in 1915 these engines were reboiled and reverted to using saturated steam. They were finally withdrawn by 1939. The Class 6Y and 6Zs were not 460s, they were 262s and 264s, but were basically of the same family. The first Class 6 engines, so built, had a 262 wheel arrangement and were delivered by Nielsen Reed & Company in 1901. The rear carrying wheels proved unsatisfactory and the engines were converted to 264s. 4 more engines were built as 264s and were delivered in 1902. All of these locomotives became Class 6Z. These 86-ton locomotives were withdrawn in 1934. The Class 7 480s. The Class 7s were the main goods locomotive in the final years of the Cape Government Railways, to a design prepared by HMBT in 1890. The locomotives in this series originally used saturated steam, had plate frames and Stephenson's link motion. The first 6 Class 7s were delivered by Dubs & Co. in 1892 and were followed by an order for 32 from Nielsen & Company, which were delivered in 1892 and 1893. A further batch of 26 engines were built by Sharp Stewart & Company, Nielsen Reed & Company and Dubs & Co. between 1896 and 1901. They had a larger boiler and an 8-wheel tender. They became SAR Class 7A and weighed in at 74 tons. Okay. Locomotive number 1007 of this class is preserved at George by the Transnet Heritage Foundation. "25 locomotives were ordered from Nielsen Reed & Company in 1900. Several of this class received large cabs and under the SAR became Class 7B. Number 1056 is also preserved in working order by the THF. Ten Cape Government locomotives were delivered from Nielsen Reed & Company in 1902. Fitted with larger boilers, the power was improved by increasing the cylinder diameter. They also had the large cabs and were later classified by the SAR as Class 7C. The Class 7s lasted into the 60s on branch line and shunting work, and the last were finally withdrawn in 1972. The Class 8 series of 480s. The Cape Government 8th class was designed as a mixed traffic locomotive suitable for goods or passenger work. The first order for Cape Government Railways consisted of 23 locomotives delivered by Nielsen Reed & Company in 1902 and 1903. They became the SR Class 8 and weighed in at 93 tons. Classes 8A, B, C and D. Several further orders for Class 8 series locomotives were placed by the Cape Government Railways and the CSAR between 1902 and 1904. These locomotives only differed slightly from each other, and photographs don't show many visible feature changes. The final order of 12 8th class locomotives came to the CGR from the North British Company and were delivered in 1904 to become the SAR Class 8F. In subsequent years, many of the classes 8 to 8F were fitted with superheated boilers and either inside or outside admission piston valves, the latter reclassified with a Class W suffix. The refined class of engines saw service on every system of this AR, but most were withdrawn by 1972. Several Class 8s still exist, but to date none are in running order, which is surprising for so large a class. The 280 Class 8X, 8Y and 8Z. All the 280s were withdrawn by 1950 and none were preserved. The Class 9 462s. We've already looked at the Hyde-designed Pacifics built in 1904 by Vulcan Foundry. These locomotives weighed in at a total of 107 tons and were used until the late 20s on light passenger workings on the Natal main line. They were superseded by the heavier Class 10 Pacifics, and no Class 9s were saved from scrapping. The Class 10 Pacifics. 15 Class 10s were designed by P.A. Hyde for use on the 80-pound track and were built by North British Locomotive in 1904. A further 10 Pacifics to the design of G.G. Elliott was placed by the CSAR with North British Locomotive in 1910. 5 saturated engines became Class 10A, while the superheated locos were Class 10B. During the 1930s, when many of these engines required new boilers, they all became Class 10BR when they were given a common boiler. The Class 10BRs worked on the passenger trains out of Johannesburg on the Reef suburban routes. They then went to the Cape Midlands system, where they were used on the main line out of Port Elizabeth. They were then put onto the shunt until scrapped in 1974, being pushed out of service by the heavier passenger trains. 12 Class 10Cs were delivered by North British Locomotive Company in 1910 and 1911 and were of lighter construction and had smaller driving wheels. As originally built, they used saturated steam but were later superheated. These 107-ton locomotives were used for several years on the Kimberley-Clarksthorpe line. 10 of these locomotives were fitted with a standard number 1 boiler and were reclassified Class 10CR, adding 5 tons to the combined weight. Several 10s, 10BRs and a 10CR are preserved or in storage. 10CR number 771 is a famous operating survivor at Lorraine Gold Mine in the Free State. The recent closure of the mine has caused this locomotive to be put into storage pending further developments at the mine. The lone Class 10D was ordered from the American Locomotive Company in 1910. Bar-framed and superheated, she was used in the Transvaal and later the Orange Free State systems, where she was withdrawn in 1931. The Class 11 282. These locomotives were designed for goods working for the CSAR. 36 engines were delivered by North British Locomotive Company in 1904 and were superheated and had Walschaerts valve gear and plate frames. These 129-ton locomotives were used between Germiston and Whitbank. During the 50s and 60s, they were transferred to shunt and trip workings. The last of the class operated at the Free State gold mines in Volcom in the early 90s. Now several are in preservation ownership. The Class 12 series of 482s. The Class 12 was the first SAR design for a 482 goods engine for coal traffic on the Germiston-Whitbank route. They were an enlargement of Henry's already successful Class 3B. The initial order of 8 engines was delivered by North British Locomotive Company in 1912, and a further 18 were supplied by the same manufacturer between 1913 and 1915. The final batch of 20 engines of this type were built by Bayer Peacock in 1921. In later years, they were given the standard number 2 boiler and reclassified 12R and weighed in at 145 tons. These engines have now all been withdrawn, with some in preservation group ownership. The Class 12A was the final D.A. Hendry design. The cylinders were increased to improve tractive effort, the boiler was redesigned and included a combustion chamber. The North British Locomotive Company and Henschel delivered 67 between 1919 and 1929. A special boiler of larger proportions was introduced for many 12As in the 1940s. Those that were reboilered became Class 12AR and could be found throughout South Africa. All are now withdrawn with the exception of this example, number 1535, belonging to the THF on lease lane to the Reef Steamers Vuur. In 1920, 30 locomotives to the Class 12 design were delivered from Baldwin. Their leading bogie had a longer wheelbase, and it was decided to classify them Class 12B. The Class 13 480 tender tanks. The CSAR converted 30 of their 35 Class H 410-2 tanks by removing the rear Bissell truck and the rear pair of coupled wheels while shortening the frame. The Class 14 series of 482s. The Class 14s are a smaller wheeled version of the Class 12 and was designed for use on the curved and heavily graded Natal main line. Because of their similarity to the Class 12, many components are interchangeable. One original Class 14 is stored by the Zanrazam Group. Between 1913 and 1915, 45 Class 14 locomotives were delivered by Robert Stevenson and Company. These 141-ton locomotives were superheated and had a Balschutz valve gear. In the 1930s, they were given the standard number 2 boiler and were classified Class 14R. Many 14Rs were seen in service on collieries and gold mines until 1998. In 1915, the North British Locomotive Company delivered 41 engines of lighter construction for use on the East London Main Line. These became Class 14A. During the First World War, the shortage of locomotive manufacturing capacity in Europe led to the ordering of 73 locomotives from the Montreal Locomotive Works. They were delivered between 1918 and 1922 and were classified Class 14C. Their distinctive features were the high running boards and the bar frame construction. In the early 1930s, some of the Class 14Cs were rebalanced to reduce the hammer blow to the track. The modified engines for branch line work were designated Class 14CB, and after reboilering with the standard number 2 boiler, the Class 14CB became the Class 14CRB. The unmodified Class 14C became Class 14CRM. The M and B suffixes indicated main line or branch line usage, respectively. They were all withdrawn from service by 1983. The famous Class 15 series of 482s. Chief Mechanical Engineer Hendry introduced the Class 15 as a large mixed traffic locomotive for use on main lines. 10 locomotives of the Class 15 were ordered from the North British Locomotive Company and placed in service in 1914. They had plate frames, Balschutz valve gear, and were superheated. In order to reduce the weight on the training wheels, steel fireboxes were fitted, and this feature became standard on large South African locomotives in later years. On later locomotives, Hendry improved the boiler by providing a combustion chamber. In this form, they became the Class 15A. 119 15As were built, the most between 1914 and 1922 by Bayer Peacock and North British Locomotive Company, with the last order supplied by JMFI in 1926. Number 1970 is the sole unreboilered version and is now preserved by the THF in working order and weighs it at 144 tons. Both the 15s and the 15As were reclassified Class 15AR when reboilered in later years. Wartime conditions led to the Class 15B being ordered from the Montreal Locomotive Works, and 30 of this type were placed in service between 1918 and 1919. They had bar frames and many other typical American features. When these engines required new boilers, they were fitted with a standard 2A type and reclassified Class 15BR. The 15BRs were used in the Western Cape until withdrawn in 1976. No 15Bs remain. However, this 15BR remains in service at the Ramfontein Estates gold mine, with another one being stored by the THF. Twelve 482 type locomotives were ordered from the Baldwin Locomotive Works in 1925. These engines conformed to SAR requirements, but also incorporated the latest American railway engineering practice and were classified Class 15C. They had bar frames, Valshit's valve gear, and were superheated. With a weight of 174 tons, they were the heaviest tender locomotives at that time on the SAR. Before they were withdrawn in 1976, the 15CAs had been reclassified Class 15CB, and some found their way into industrial service. 21 improved Class 15Cs were ordered from the American Locomotive Company in 1926, featuring a design change to the frames, and were reclassified Class 15CA. Further orders for the 15CAs were placed with Alco and Baldwin of the USA, Bredar of Italy, and the North British Locomotive Company. 83 engines were delivered between 1926 and 1930. The 15CAs and CBs saw service until the end of steam in most regions, and several have been preserved. A further development of the Class 15 was introduced by A.G. Watson and placed in service during 1935 and 1936. They had a vastly enlarged boiler of the standard 3B type and rotary cam valve gear. 44 of these 168-ton Class 15E engines were delivered by Robert Stevenson, Henschel, and the Berliner Maschinenbau. Initially placed in service between Cape Town and Beaufort West and Haar, they were transferred in the 1950s as a class to Bethlehem, where they worked to Harrismith, Bloemfontein and Kroonstad. In 1976, the class was sold to the then Rhodesian Railways, while the rest of them were withdrawn from regular service in 1973. Number 2878, though, is kept in running order for enthusiast specials at Bloemfontein. When additional locomotives of the Class 15E type were required, Mr. Day specified a change to conventional Valshit's valve gear, resulting in the legendary Class 15F. The first 65 engines of this type were built by Henschel and Berliner Maschinenbau and were placed in service during 1938 and 1939. Initially, they did not have smoke deflectors and were hand-fired like the 15Es and weighed in at 178 tons. Bayer Peacock and Company and the North British Locomotive Company recommenced manufacture of the 15Fs in 1945, and by 1948 there were 255 engines of this type in service. The new series were fitted with smoke deflectors, mechanical stokers, and had vacuum brakes on the driving wheels, which added 5 tons to the overall weight. 15Fs saw service in every mainline system in South Africa up to almost the end of regular steam operations. In later years, many of the Class 15Fs acquired the larger tender from scrapped Class 23 locomotives. Some 15Fs are operating with the THF tours and preservation groups. A number 2916 has been converted to oil burning, almost qualifying a subclass classification. The Class 16 series of 462 Pacifics. The Class 16s were designed primarily for fast passenger service. The first batch consisted of 12 engines delivered in 1914 from the North British Locomotive Company. They had plate frames with Walschaerts valve gear and were superheated. When later they were given new boilers, they weighed in at 137 tons, and the standard 2B boiler converted them to Class 16R. 2 locomotives of the Class 16A were delivered in 1915 from North British Loco, and they had 4 cylinders instead of the usual 2. The Walschaerts valve gear was modified to accommodate the design for 4 cylinders. They were withdrawn by 1945. 10 Class 16Bs were placed in service in 1917 and 1918, built by North British Locomotive Company. They were much the same as the first order, except they had Hendry's wide cab. 116B, number 805, has been cosmetically preserved by the THF after having stood at Johannesburg Station for many years. Between 1919 and 1921, the North British Locomotive Company delivered 30 Class 16Cs. They were similar to both Classes 16B and 16, except that a combustion chamber was fitted to the boiler. Classes 16B and 16C were given the standard number 2 boiler and all became Class 16CR because of their similarity. The last 16CR saw active work at the St Helena gold mine in the Free State. A few have been preserved. In 1925, two Pacific-type locomotives were delivered from Baldwin in the USA and became known as the Class 16D, or Big Bertha by the crews. They were extremely similar in design to the Class 15Cs and weighed in at 159 tons. They worked on passenger duties over the years in the Northern Cape, Free State and finally Cape Town. Number 860 is preserved by the THF in the Western Cape. The loco made railway history on a 1926 run on the Union Express between Johannesburg and Cape Town and ran on the train throughout. A further 14 locomotives were delivered from Baldwin and Hohenzollern in 1928 and classified 16DA. They had widened firebox in line with the Class 15CA modifications. A further 6 engines with even larger fireboxes were delivered in 1929 from Henschel and retained the 16DA classification. One of this class, number 879, was fitted with Caprotti valve gear for test purposes. This loco, now fitted with Valschetz gear, is preserved by the THF. The 16Ds and 16DAs were relegated to suburban work until withdrawn in 1973. Six Class 16Es designed by A.G. Watson were built by Henschel in 1936 and placed in service out of Johannesburg, hauling crack express trains such as the Union Limited. These 167-ton locos are fitted with 6-foot drivers, the largest on any 3'6" system, and with a 9'3" pitched boiler centerline. These were the most impressive Pacifics to see service on the SAR. Two of these locos, number 857 and 858, are retained by the THF and are used for enthusiast specials. Class 17 480 tender tanks. 21 A-class 482 tank engines, built by Dubs & Co. between 1890 and 1900, were modified for shunting work. Various tenders were added to give an improved supply of coal and water. The Class 18 210-2. Two Class 18s with a 210-2 wheel arrangement were built by Henschel in 1927. The engines had 3 cylinders, the 2 outer ones having Valschetz valve gear, and the inner one controlled by Gresley conjugated valve gear. They were the most powerful, non-articulated locos ever to see service on the SAR. The Class 19 series of 482s. The Class 19s were designed primarily as a 482 branch line locomotive. The first 4 Class 19s were delivered by Berliner Maschinenbau in 1928. These 136-ton locomotives were superheated with bar frames and Valschetz valve gear and proved successful. One of the Class 19s was reboilered in 1966 with a 1A boiler and became the sole member of the Class 19R. All of these engines were withdrawn by 1977. The Class 19A was designed for use on some of the more lightly laid branch lines. 36 were built by the Swiss Locomotive Works Winterthur in 1929. 5 of these engines were reboilered with the number 1A boiler becoming Class 19AR. These 125-ton locomotives were withdrawn by 1977. One loco is preserved at the Umgeni Steam Railway in Pinetown. In 1930, a further 14 Class 19s were built by Berliner Maschinenbau, with the wheelbase of the front bogie increased to improve clearance with the cylinders and bogie wheels. It was decided to classify them Class 19B. One of the 19Bs was also reboilered with a number 1A boiler to become Class 19BR. The loco here was last seen in service on the Welcome gold mines. Another 50 Class 19 locomotives were delivered by the North British Locomotive Company in 1935, and these engines were fitted with a rotary cam valve gear. These 147-ton locomotives had the standard number 1A boiler, and they became the Class 19C. They were placed in service on the Reef, Eastern and Western Cape, and later were concentrated in Cape Town, where they worked various branches. They were withdrawn from service in 1978. 2439 is kept in service and is used occasionally for specials by the THF at Forby. One 19C was experimentally fitted with the extended spark arrestor system seen here that was fortunately not standardized on the rest of the class. The Class 19Ds. Later batches of the 19s were ordered during the period of tenure of W.A.J. Day as Chief Mechanical Engineer, but the rotary cam valve gear was replaced by Valschutz. These became Class 19D, and in other respects were identical to the Class 19C. 135 engines of this type were delivered between 1933 and 1939 by Krupp, Borsig and Skoda. The 20 locomotives built by Krupp were fitted with domeless boilers. In 1949, a further 50 Class 19Ds were supplied by Robert Stevenson and Hawthorns. These were similar to the pre-war 19D, except they were fitted with vacuum brakes. The final order of 50 locomotives of this type was from North British Locomotive Company in 1949, and they were provided with a new type of tender known as the Vanderbilt, designed with a cylindrical water tank and 6-wheel Buckeye bogies. These 153-ton locomotives had extensive use on every branch line of the SAR, and some are still in service on industrial workings. During the late 90s, two locomotives at THF in Cape Town, numbers 3322 and 3334, were converted to oil burning for use in dry conditions, where line-side fires are a danger. This would have probably made, along with 2644, a subclass during steam days. In 1979, a Class 19D, number 2644, underwent extensive modifications. The steaming rate was improved by fitting a LEMPOR exhaust, and coal consumption was reduced by using a gas producer firebox. The success of this experiment led to the construction of the Class 26. The 19D has been preserved at the Sanraz and Krugersdorp site. The Class 20 210-2. The prototype of this class was designed by A.G. Watson in 1934 for goods traffic in southwest Africa. The engine was built in the SAR works at Pretoria out of locally obtained scrap loco parts and some imported equipment, such as the bar frames. In 1948, it was decided to fit condensing apparatus to recycle water in arid areas. A condensing tender was ordered from Henschel in 1948 for this trial conversion, and the loco weighed in at 158 tons all up. Class 21 210-4. This design represented the maximum power obtainable from a 10-coupled locomotive limited to a 15-ton axle load on 60-pound track. The North British Locomotive Company built the sole engine of this class, number 2551, delivered in 1937. This locomotive was based on the Eastern Transvaal system. The Class 21 had a standard number 3B boiler and had Valschatz's valve gear. Smoke deflectors were installed during service. The total weight was 172 tons. The locomotive was unfortunately scrapped in 1952 after 15 years' successful service. The proposed Class 22 210-4. A design for a 210-4 heavy goods locomotive was prepared in 1935 by A.G. Watson. It represented the maximum power obtainable from a 10-coupled locomotive with 22-ton axle loads on 96-pound track. This 250-ton locomotive was never built because the requirements of the railways at that time were for general-purpose locomotives rather than a purely heavy freight hauler. As a rule, it appeared that the 10-coupled designs never took off on the SAR, unlike the US railroads, owing to the lack of success of the classes like the 18s. Class 23 482. This class was designed by CME Day's staff in 1936 as an all-purpose locomotive capable of operating on 80-pound track in open, arid regions. Initially designed to have 5 or 6-inch diameter driving wheels, they were finally fitted with 5'3" wheels. The centre line of the standard number 3B boiler was lower and the chimney slightly longer than the similar-looking Class 15F. A total of 136 Class 23 locomotives were supplied, 98 by Henschel and 38 by the Berliner Maschinenbau in 1938 and 1939. The locomotives were fitted with Valschatz's valve gear and weighed 221 tons. A 12-wheeled tender with 9,500 gallon capacity was fitted. This locomotive, number 3300, has been retained for hauling special trains by the THF in Bloemfontein. The Class 24 284. The Class 24 was a branch line locomotive introduced in 1948 for operation on 45-pound track in southwest Africa. They were intended to replace the old classes 6, 7 and 8 locomotives still in service there. 100 locomotives of this Berkshire wheel arrangement, the only examples on the SAR, were constructed by the North British Locomotive Company. One of these locomotives, number 3675, was the 2000th machine built by the company and its predecessors for South Africa, and is now in service to the THF in George. The locomotives have an integral steel mainframe cast integrally with the cylinders. They were fitted with the standard number 1 boiler and Valschatz valve gear. The tender is of the Vanderbilt type, and they weigh in at 108 tons. In recent years, they saw service on SAR branch lines and are a well-known sight on the Neisner Museum line. The 25 Class 484s. After the legendary 15F, these are the best-known steam locomotives on the SAR and represent the zenith of steam power from the mid-1950s through to the 1990s. The Class 25 locomotives were designed to operate on the Toes River to Haar section of the Cape Town to Johannesburg main line, a region which suffers severe water shortages. The Class 20 condensing locomotive tests had proved successful, and orders were placed for 90 Class 25s with Henschel and the North British Locomotive Company. Henschel supplied the first locomotive and 60 condensing tenders, and North British the remaining 89 locomotives and 30 tenders in 1953 to 1955. The exhaust steam was circulated to an air-cooled condenser in the tender. The tender had 5 steam-driven fans mounted on the top surface to draw air through the condensing equipment. The induced draft fan in the smoke box gave the engine its characteristic sound when running. These 234-ton locomotives had Valschatz valve gear, roller bearings throughout, and a single cast steel main frame which included the cylinders. Between 1974 and 1980, all except 2 of the Class 25s had their condensing apparatus removed and were converted to free-steaming Class 25 NCs. The tender's original underframes have been retained with round-top water tanks that coined the name sausage dogs. Number 3511, the last working condenser, is out of use at present, requiring considerable repairs. 50 new engines of the Class 25 NC non-condensing type were ordered in 1953, 11 from the North British Locomotive Company and 39 from Henschel. Apart from the condensing apparatus, they were identical to the original Class 25s, but with standard tenders. At least 2 25 NCs, including numbers 3417 and 3501, have been converted to oil burning. This conversion would have also prompted a subclass designation in proper SAR days. In recent years, 25NC number 3454 was converted to incorporate a Lemper exhaust system characterized by double side-by-side chimneys at Beaconsfield in Kimberley. This locomotive now forms part of the THF fleet for specials in Bloemfontein. Class 26484. Following the producer gas combustion tests carried out on Class 19D number 2644, it was decided that a similar conversion would be conducted on a Class 25NC. Number 3450 was rebuilt at the Salt River Workshops in 1981 under the supervision of David Wardell of the Chief Mechanical Engineers Department. It incorporated design improvements by Argentinian locomotive engineer L.D. Porter. It has been reclassified SAR Class 26. The exhaust system has been improved by fitting a double Lemper arrangement. There were also a number of other chiefly mechanical improvements on the locomotive. The increased power output resulted in frequent slippage. No doubt a 210-4 arrangement would have been a better design. Painted in this distinctive colour, she has been nicknamed the Red Devil and is now preserved in Bloemfontein for the THF. The Class S 080. This class was the first locomotive specifically intended for shunting work. 14 engines were delivered by Henschel in 1928 and 1929. They were superheated, had bar frames and Walschaerts valve gear. They worked mostly in the Transvaal before being withdrawn in 1976. The last two of these 133-ton engines were operated at Grootvlei Mine until the late 1980s. The Class S1080. The Class S1 was the first series of steam locomotives to be designed and built by the SAR. The first of the Class 12 S1s were delivered from Salt River Workshops in 1947. They had bar frames, Walschaerts valve gear, and were superheated. Many features were similar to the existing Class S, but their boilers were much larger. They weighed in at 140 tons. A further 25 engines were built by North British Locomotive Company in 1954. They were used mainly in marshalling yards on the Transvaal. Several are preserved, but none are currently in service. Class S2 080. Designed for working on lightly laid harbour track, the Class S2 had a small boiler to keep its weight within the tight specification. The loco weighed in at only 47 tons, but the tender was 54 tons. 100 were built by Krupp in 1952 and 1953 and were placed in service mainly in the main harbours. They were superheated, had Walschaerts valve gear and single-piece cast frames with separately attached cylinders. They were all withdrawn by 1983, but several are in preservation. The Class KM, Kitson-Mayer, 060 plus 060. This locomotive was one of two to survive in the SAR until 1918, built by the Kitson Locomotive Company. This engine consisted of two sets of coupled driving wheels under the boiler, both free to swivel in relation to the boiler. The rear set of cylinders discharged exhaust steam immediately behind the cab, the forward cylinders discharging in the normal way up the chimney. We now review the remainder of the articulateds, the first series of which were the Mallet-type locomotives. The Class MA Mallet, 2660. A Mallet articulated locomotive was ordered from the American Locomotive Company by the Natal Government Railways for banking heavy goods traffic. It became SAR Class MA and was placed in service in 1909. Class MB Mallet, 2660. A further 5 somewhat similar Malays were ordered for the CSAR from American Locomotive Company and were placed in service in 1910 on the Natal Main Line. The Class MC Malay, 2660. A third order of 10 Malays from the Natal Main Line were ordered in 1912. Similar to the MB class, they were built by the North British Locomotive Company and had Walschaerts valve gear and were initially not superheated. Class MC1 Malay 2660. These 12 locomotives were a superheated version of the Class MC, giving much improved performance. The Class MD Malay 2662. One compound Malay was ordered by the CSAR for use on coal trains on the Whitbank-Germiston line. The Class ME Malay 2662. Designed by the CSAR as a branch line Malay locomotive capable of running on lines laid with 45-pound rail, the single Class ME was delivered by the North British Locomotive Company in 1912. It was the only SAR Malay that had 4 high-pressure cylinders instead of the usual compound arrangement. Class MF Malay 2662. 14 of these compound-type locomotives were delivered by American Loco in 1910 and 1911 for use on the Whitbank-Germiston line. Class MG Malay 2662. A single Class MG was built basically to the Class MF design by Alco in 1911 and involves several modifications. Class MH Malay 2662. The largest Malay in South Africa was designed by the SAR in Pretoria under D.A. Hendry, and the 5 locomotives were built by North British Locomotive in 1915. They were originally used on the Whitbank-Germiston line and then later on the Glencoe-Vryheid route. At the time of their construction, they were the most powerful locomotives in the world on the Cape Gauge. These 167-ton locomotives were superheated, compound, and had Walschaerts valve gear. Transferred to the Orange Free State in the 1930s, they were all withdrawn by 1940. It is indeed unfortunate that none of these locomotives were preserved. Class MJ Malay 2660. The Class MJ was a Hendry design for a branch line Malay locomotive, and an order for 10 was placed with Maffei of Germany in 1914. Another order was placed with the North British Locomotive, who delivered them in 1917. Class MJ1 Malay 2660. Similar to the Class MJ, 8 MJ1s were ordered from the Montreal Locomotive Works in Canada and were delivered in 1918. Their boilers were larger, and the main feature was the sandbox mounted on the boiler in North American style. The locomotives were superheated and had Walschaerts valve gear. They were withdrawn by 1960, slightly before the older Class MJ. Long after all the Malays in South Africa had eventually been scrapped, 2 identical Class MAs built for the Mozambican railways still lie abandoned in Tep Province at Moatize. The Malay locomotives were never really a success on the SAR, where the Garrett type, capable of negotiating tighter curves, eventually became more effective in service. At the same time that the Malays were being put into service, it was decided to experiment with the Bayer-Garrett design. The single Class GA, weighing 133 tons, was put into service in 1921, the first of this type on the Cape Gauge. The Class GB Garrett 262 plus 262. 7 further experimental Garretts for branch line use were supplied by Bayer Peacock in 1921 and 1924. They were superheated, had plate frames, Walschaerts valve gear, and weighed in at 76 tons. The trailing truck reduced flange wear significantly. They worked for many years on the Berkeley East Line until 1967, but number 2166 has been preserved for the THF Museum. The Class GC Garrett 262 plus 262. This was a heavier, 96-ton, and more powerful branch line Garrett, which was supplied by Bayer Peacock in 1924 and 1925. The Class GCA Garrett 262 plus 262. 39 were built in 1927 and 1928 by Krupp of Essen to the same specifications as Class GC. Class GD Garrett 262 plus 262. 14 more powerful and heavier locomotives, based on the GC, were delivered by Bayer Peacock in 1925 and 1926 for branch line use. Class GDA Garrett, 262 plus 262. The 5 Class GDAs were built to the same specification as a GD and were built by Link Hoffmann Werke Breslau and placed in service in Cape Town in 1929. Class GE Garrett, 282 plus 282. This class of Garrett was the first 8-couple design for 60-pound rail. 3 orders were placed with Bayer Peacock, of which the first 6 were delivered in 1925. The 10 of the second order in 1926 were identical mechanically, but had revised water tanks and coal bunker. Class GEA Garrett, 482 plus 284. At 187 tons, the GEA had little in common with the earlier GE. 50 locomotives were built by Bayer Peacock between 1945 and 1947. The locomotives were superheated, had bar frames, Varshitz valve gear, and modern tanks. Withdrawn by 1976, they worked Western Cape and Natal branches. Number 4023 is based at 4x for special workings. This locomotive was fitted with an extended chimney spark arrestor device that, at the same time being unsuccessful, was an exceedingly ugly experiment. Class GF Garrett, 462 plus 264. This branch line Garrett was designed for both passenger and goods trains. 37 were produced by the German firm of Hannemeg in 1927. Followed by a further 18 in 1928. A third order for another 10 was supplied by Maffei in 1928. These 145-ton locomotives were superheated, had bar frames and used Varshitz valve gear. These engines saw service in Natal, the Transvaal, Free State and the Eastern Cape. Several are preserved, but 2401 is the only one in service. The Class GG Garrett, 262 plus 262. The only engine of Class GG was built by Bayer Peacock in 1925 and was intended for fast passenger duty. This 147-ton locomotive was only fitted with a 2-wheel leading Bissell truck and wasn't stable at high speed. The Class GH Union Garrett, 462 plus 264. 2 Class GH locomotives were built by J.A. Maffei in 1928. They were put in service on passenger trains out of Cape Town on the main line to the north, but were found to be in excess of the loading gauge. The Class GK Garrett, 262 plus 262. The New Cape Central Railway, an independent privately owned company, ordered 2 Garretts from Bayer Peacock in 1923. Similar to the GB design, the cylinders were larger and the locomotives heavier. The Class GL Garrett, 482 plus 284. Specifications were drawn up for a Garrett with a power equivalent of 2 14-class locomotives by CME Colonel Collins in 1928. 2 engines of the resultant Class GL were delivered by Bayer Peacock in 1929, with another 6 following in 1930. These engines at 211 tons were the most powerful steam engines to operate on the SAR with a 78,000-pound tractive effort. The locomotives were superheated, had bar frames, Varshitz valve gear and a mechanical stoker. They worked Natal's secondary main lines until withdrawal in 1972. One locomotive has returned to the UK to a museum in Manchester, whereas number 2351 now operates at the THF at 4x. The Class GM Garrett, 482 plus 284. 16 locomotives of the Class GM were delivered by Bayer Peacock in 1938, in order not to exceed the 15-ton axle limit. An auxiliary water tank was trailed behind the engine. Garrett classes GMA and GMAM, 482 plus 284. As successor to the Class GM, 115 of these Garretts for use on 60-pound rail were delivered between 1954 and 1956. The orders were completed by Bayer Peacock, the North British Locomotive Company and Henshaw. The only differences between the 2 subclasses were the coal and water capacities. and the GMA weighed in at 187 tons, with the GMA-M 4 tons heavier. The locomotives were modern in design, having one-piece cast steel frames and roller-bearing axle boxes. They were superheated and were fitted with Varshot's valve gear. Like the GMs, they trailed an auxiliary water tank. These locomotives saw service on most secondary lines in the country. They were the last class of Cape Gauge Garretts in regular service with the SAR and withdrawn in 1984. The last Cape Gauge steam locomotive delivered to the SAR was a GMA, number 4170. The Class GO Garrett, 482 plus 284. This was a lighter version of the GMA design for use on branches laid with 45-pound rail. Tractive effort was reduced and coal and water capacities lessened to reduce the overall weight to 172 tons. Many other parts are interchangeable with the GMA. 25 were ordered from Henschel in 1954. Their final term of duty was on the Natal North Coast lines before being withdrawn from service by 1975. The Class FC modified Fairley, 262 plus 262. A rival design to the Garrett, the modified Fairley locomotive was developed by the North British Locomotive Company. The front and rear water and coal bunkers did not swivel with the front and rear engines, but were attached on one rigid frame with the boiler and cab. The Class FD modified Fairley, 262 plus 262. The Class HF modified Fairley, 282 plus 282. The Class HF was the Fairley equivalent of the Class GE Garrett. 11 locomotives were built by Henschel in 1927 and 1928. The Class U, Union Garrett, 262 plus 262. J.A. Maffei delivered 10 Class U locomotives to the Union Garrett layout in 1927. They were fitted with bar frames and Varshot's valve gear. Fitting of mechanical stokers was one of the arguments in favour of the Union Garrett because of the rigid rear frame. The design was not the success it was expected to be, and these locomotives were withdrawn by 1958. So ends one of the most extended and varied steam locomotive programs in the world, spanning nearly 100 years, or, if one adds in the work on number 3450, nearly 130 years. Many interesting designs were submitted or proposed towards the end of the steam era for varied or more powerful steam locomotives. Had the relentless diesel and electric inloads not proceeded, and air brake systems on steam had been implemented, no doubt many of these would have become reality. At this stage, we draw a line on Cape Gauge steam in this country and have a look at the varied 610mm narrow gauge steam. In fact, steam on the narrow gauge tended to outlast that on the Cape Gauge network due to the dieselization not proceeding as quickly in this area. Larger simple types, the North American Mallet designs, might have been more successful in heavy trains in the interior, especially if fitted with air brake systems. This painting by Kenton Lloyd invokes the atmosphere of the last Mallets running the Transcape branch in the 1950s, since very few photographs of Mallets in service are known to exist. Class NG1 040 tank. These engines were supplied in 1899 by Kerr Stewart and were plate-framed with Stephenson's link motion. The two locomotives were used by the British troops in eastern Johannesburg for construction work during the Boer War. Class NG2 042 tank. Two 042 saddle tank locomotives were supplied by the US company Dixon Manufacturing to the Rand mines in the Transvaal. Class NG3 462 tank. These 6 locomotives were ordered for use on the South Coast branch to Donnybrook, which is 158 kilometers long. Class NG4 462 tank. 7 locomotives were built by Kerr Stewart and Company between 1911 and 1914. Class NG5 282. 6 locomotives were ordered from Henschel in 1922 for use on the Opvryf branch in southwest Africa. Class NG6 440. In 1896, some 45 440 locomotives with Stephenson's link motion were supplied by the Falcon Engine and Car Works Loughborough and D. Drummond and Son Glasgow. Class 7. No locomotive was officially designated here. It is surmised, however, that these 4 Baldwin 260 locomotives, supplied between 1902 and 1911, were to have been classified NG7. Class 8. Likewise, no Class 8 existed, but these 4 Bagnall 460s, supplied in 1903, 1913 and 1914, were supposed to have been allocated to the Class NG8. At this time, several other narrow gauge locomotives were unclassified on the SAR, as follows. NG33 and NG34, 462 tanks. Numbers NG1 and NG2, 462 tanks. 2 small side tank locomotives were built in 1907 by the Hunsnet Engine Company of Leeds to the design of D.A. Hendry. Number NG20, 040 tank. 1 locomotive was supplied by Manning Wardle in 1902 for use on the Aventura branch and was classified Type C by the CGR. NG91 and 92, 040 tank. 2 side tank locomotives of Avonside Standard Imperial class were built in 1899 for use by Rand Mines Limited. Class NG9 460. 6 locomotives were delivered by the Baldwin Locomotive Works in 1915 and 1916. They were erected at the Uitenhage workshops and placed in service on the Aventura branch. Class NG10 462. 6 locomotives of this class were also built by Baldwin and placed in service in 1916 on the Aventura branch. They had outside bar frames and Valschutz valve gear. Class NG G11 Garrett, 260 plus 062. The first 3 narrow gauge Garrett type locomotives of the SAR were supplied by Bayer Peacock in 1919. Class NG G12 Garrett, 262 plus 262. This was the smallest narrow gauge Garrett in South Africa, designed to operate on 20-pound track. Class NG G13 Garrett, 262 plus 262. This design was to become the standard narrow gauge Garrett for the SAR. 12 locomotives were supplied by Hanomag from 1927 onwards. Class NG G14 Garrett, 262 plus 262. Slightly larger and more powerful than the NG G12, the sole locomotive of this class was built by Hanomag of Germany and placed in service in 1931. She ended her working days at Humid Road in 1952. Class NG 15 282. For the Opvryf branch in southwest Africa, 3 282 locomotives were ordered from Henschel in 1931, similar to the existing German HD design, which we will see shortly. In addition to improvements in the wheel spacing, the tender was enlarged to improve the coal and water carrying capacity. These locomotives were over 5 tons heavier than their predecessors. Repeat orders for further engines were obtained for use in southwest Africa for the next 27 years. All the NG15 class was sent to the Aventura branch after conversion of the southwest African system to Cape Gauge in 1960. Some are in operation in South Africa today, whilst others are in service in Australia and Wales. Class NG G16 Garrett, 262 plus 262. In 1937, John Cockrell supplied 4 locomotives, numbers 85 to 88, which were similar to the NG-G13s. They were reclassified Class NG G16 due to the roller bearings in the carrying axles. These locomotives operated mostly in Natal. A further 15 engines were supplied in 1939 and 1951 by Bayer Peacock for the Natal branches and the Aventura line. A further 7 were delivered in 1958 direct to Natal and Aventura. The last order for 7 engines was particularly significant, as these were the last steam locomotives to be ordered by the SAR. These engines were manufactured by Hunslet Taylor of Germiston and were numbered NG149 to NG156. Class NGG 16A. The Alfred County Railway in Port Shepstone took over operation from the SAR in 1988 and operated a number of inherited Class NGG 16s. 2 locomotives, numbers 141 and 155, were converted in the early 90s and on the same lines as the Red Devil to operate with improved combustion and lever exhaust systems, amongst other modifications. Narrow gauge steam locomotives, ex-German Southwest Africa. In 1915, control of the railways of the former German Southwest Africa passed to the Director of Railways in Windhoek, and then in 1922, these lines were absorbed into the SAR. The locomotives were unclassified on the SAR. Class Jung, 062 tank converted to 062. Class HA, 062 tank. 10 locomotives of Class HA were built with Allen valve gear by Henschel for the Otavie line in 1904. Only one, number 22, saw service on the SAR. Class HD, 282. In 1912, Henschel built 3 282 tender locomotives for the Otavie line for use on the Swakopmund-Karibib section. Class HB, 062 tank. Electric locomotives. The South African system of DC and AC electrified operations is the most extensive in the Southern Hemisphere with the largest locomotive fleet. The Class 1E and 1ES Bobo wheel arrangement. The line between Pietermaritzburg and Glencoe was electrified between 1924 and 1926. For this system, 78 3-kilovolt electric locomotives of Class 1E were ordered from Metropolitan Vickers and Company in Manchester. The locomotives are rated at 896 kilowatts and weigh in at 68 tons. A further 94 locomotives of this class were built up to 1945. They've all been withdrawn, with several being preserved, but none are currently in operation. Class 2E, Bobo wheel arrangement. In 1937, 3 electric locomotives of Class 2E were built in Germany by Henschel, fitted with Siemens electrical equipment. Class ES, Bobo wheel arrangement. 12 locomotives of Class ES for shunting work were constructed by the SAR in Pietermaritzburg workshops between 1935 and 1938. 12 more were ordered between 1938 and 1964 from Metropolitan Vickers. The traction motors and bogies are interchangeable with the Class 1E, and the electrical supply is 3 kV DC. These locomotives weigh in at 68 tons. They are now withdrawn. Class 3E, CO wheel arrangement. These, the first 6-axle electric locomotive designs, were ordered in 1944 from Metropolitan Vickers. The 28 3 kV DC locomotives of this class were placed in service in 1947 to 48 on the Witwatersrand. These 114-ton locomotives had a continuous rating of 1704 kilowatts. The Class 4E, 1 CO1 wheel arrangement. 40 of these Class 4E 3 kilovolt DC locomotives were supplied between 1952 and 1954, jointly by the General Electric Company and North British Locomotive Company. They were designed for the electrified section from Worcester to Towes River. At that time, they were the most powerful electric locomotives in the Cape Gauge. The maximum safe speed is 97 kilometers per hour. They had a continuous rating of 1878 kilowatts and weighed in at 157 tons. All are withdrawn. This unit is based at Belleville in Cape Town for the Transnet Heritage Museum. Class 5E, Bobo wheel arrangement. The Series 5E to 6E electric locomotives make up one of the largest classes of electric locomotives in the world today. The English Electric Company initially supplied 60 vacuum brake Class 5E locomotives in 1952. They had a continuous power rating of 1,300 kilowatts. A further 160 3 kV units were delivered between 1955 and 59, but are now withdrawn except for those in industrial service. A later series were manufactured in South Africa by the Union Carriage and Wagon Company of Nigel, incorporating imported AEI electrical gear. These were the first mainline electric locomotives constructed in South Africa. A total of 690 Class 5E1s were delivered between 1959 and 1969, each weighing in at 86 tons. The maximum speed of all the 5Es is 97 kilometers an hour. The design of the bogies on the 5E1 is different to the 5E, and in addition, the 5Es are air-braked as well as vacuum-braked. Nowadays, these locomotives are used mainly for passenger rather than freight workings. Class 6E, Bobo wheel arrangement. The 6E design incorporated improvements in motor design to increase the power rating to 2252 kilowatts continuous, and they had anti-slippage devices. The 80 Class 6E locomotives built by Union Carriage in 1970 and 71 have air bellows between the bogies and frames to transfer power to the rails. The improved Class 6E1 has a sophisticated series of traction links visible on the outside of the bogie to optimize traction. Between 1969 and 1985, some 865 of these units were supplied by Union Carriage using AEI motor equipment. The maximum safe speed of these locomotives is 113 kilometers an hour. But the Class 6E1 is the most numerous class of locomotives to have operated on the SAR, and these locos are confined to freight workings on the 3 kV lines. The Class 7E series of CO locomotives. The Class 7E locomotives were designed primarily for goods services on the 25 kV 50 Hz electrified lines. The continuous power rating is 3,000 kilowatts. The series incorporates state-of-the-art thyristor electronics control systems to operate on the modern AC SPURNet network. The Class 7E and 7E2 locomotives were built by a European consortium called the 50 cycles per second group. The 7E1 and 7E3 classes were designed by Hitachi of Japan, with the South African firm of Dorbale contracted for the mechanical components and assembly. The weights of these classes vary between 123 and 125 tons. The Class 7E1 locomotives were acquired for multiple unit operation on the Ermelo-Richards Bay coal line and only have a single cab. The 7E2 and 7E3 class bogies have a slightly shorter wheelbase than the 7E and 7E1 in order to reduce flange and rail wear and other construction differences. Class 8E, Bobo wheel arrangement. The Class 80 is a modern electric shunting locomotive designed for the lines electrified at 3 kV DC. Class 80 shunting locomotives were supplied by a consortium of Brown Bavarian Co. of Switzerland and Siemens of Germany. The mechanical components were assembled by the Union Carriage and Wagon Company and placed in service between 1983 and 1985. The Class 9E CO locomotives. These were unique machines for the 860-kilometre long railway to link the iron ore mines at Sishen with the port of Saldanha Bay, operated by the South African Iron and Steel Corporation, ISCOR. It was, unusually, electrified at 50 kV compared with the SAR's 25 kV high voltage electrification. The units regularly operate in threes on trains over 2.3 kilometres in length. The continuous power output is 3840 kilowatts. The Class 10E CO wheel arrangement. 50 Class 10Es, 100 Class 10E1 and 50 Class 10E2s were placed in service between 1985 and 1992 for use as standard goods locomotives on the 3 kV system, principally to replace the aging Class 5E and 6E series. The 10Es and 10E1s are rated at 3090 kilowatts and the Class 10E2s at 3330 kilowatts. The units were mechanically assembled by the Union Carriage Works at Nigel. The 10Es and 10E2s are fitted with Japanese Toshiba equipment, whereas the 10E1s have GEC machinery. The Class 11E CO locomotives. 45 Class 11E locomotives for the Ermelo Richards Bay 25 kV AC coal line were delivered between 1985 and 1987 and have a continuous power rating of 3,900 kilowatts. 4 of these 170-ton units can haul 200 loaded coal wagons of a train weighing more than 21,000 tons. These units are able to produce up to 4,500 kilowatts of rheostatic braking power on the downhill trains. Because the locomotives are used in multiple, only a single cab is provided. Class 12E Bobo locomotives. 5 3-kilovolt DC locomotives were placed in service in 1983 for use on the Metroblitz new high-speed passenger trains introduced between Johannesburg and Pretoria. They have the same power output as the 6Es, but a higher gear ratio, allowing a maximum safe speed of 150 kilometers an hour. Originally attached at each end of the Metroblitz train, only a single driving cab is provided at each end of the unit with a guards unit at the opposite end. They were built at the Union Carriage and Wagon Company and are now used exclusively in pairs on the Blue Train service. Class 14E Bobo wheel arrangement. The Class 14E is the first dual 3 kilovolt DC, 25 kilovolt AC electric locomotive in operation on Spurnet. 3 Class 14Es were built in 1990 and 10 Class 14E1s were ordered in 1994. They were designed and built at Union Carriage to the same 50-cycle consortium that was responsible for the 7E series. These 92-ton locomotives are the most powerful machines in the system and are rated at 4,080 kilowatts. They're exclusively used on essentially non-stop container traffic trains. Electric multiple units, or EMUs. Although not strictly classified as locomotive types, the electric motor coach units that characterize and indeed monopolize the commuter lines around South Africa's metropolitan areas deserve mention. The original wood-bodied steel-frame 1.5 kV DC units were placed in service between Cape Town and Simonstown in the Cape Peninsula and were classified 1M1. From 1937 onwards, newer 3 kV wood-bodied motor coach sets were supplied for the newly established commuter services on the Rand by Metro Camel. Between 1954 and 1955, Metro Camel supplied 31 Type 4 M1 units for use in 3 kV lines. Some 50 upgraded 4M2 wooden coach units were placed in service between 1955 and 1958. Between 1958 and 1960, Metro Camel supplied new all-steeled EMUs. These totaled 105 motor and 345 trailer units. Locally built 5M2A units, assembled at Union Carriage with imported electrical equipment, were supplied for some 25 years between 1961 right up until 1985. The specification was largely similar to the 5M2 units. These units were built in their hundreds to replace the aging 4M wooden-bodied stock and to supplement increased commuter volumes. In the late 1980s, experimental stainless steel EMU sets were supplied by Hitachi, designated 6M, and MAN Siemens, designated 7M. The production contract, designated 8M, was awarded to Hitachi, who supplied 48 driving units and 96 trailers for use in the Cape Town area. The motor units can accommodate 246 passengers, weigh 71 tons and are rated at 1,270 kilowatts. Diesel locomotives. Class 61, originally Class 1 DH, BB. 7 diesel hydraulic locomotives were ordered from Henschel in Germany in 1958. Class 31, formerly Class 1 DE, Bobo units. 45 were delivered by the General Electric Company of the USA during 1958. Their classification of the manufacturer was type U12B. The locomotives are fitted with 4-stroke V8 turbocharged Cooper Bessemer diesel engines driving a DC generator. 4 axle-hung traction motors are fitted to the 75-ton engines. A maximum of 3 locomotives can be coupled together in multiple units, each rated at 900 kilowatts. Class 32, 1CO, CO1. The Class 32 diesel-electric locomotive was ordered for light track railway operations in southwest Africa. In order to keep the axle loading within the limits of 45-pound track, the bogies were fitted with a bony truck at the outer ends. 125 of these 93-ton locomotives were ordered from the General Electric Company of the USA. Class 32 locomotives have one 4-stroke V12 turbocharged and after-cooled General Electric diesel engine driving a DC generator, rated at 1340 kilowatts. Class 33 COCO. The Class 33 was the first COCO mainline diesel-electric locomotive supplied to the SAR by 2 different manufacturers. 65 Class 33s and 115 similar 33-400 series, type U20C, were supplied by General Electric Company. 20 of the 33-200 high-nose series were supplied by the Electromotive Division of General Motors to manufacturers type GL26MC in 1966 and 1967. Class 34 COCO. Class 34 represents the final development of the mainline COCO diesel-electric locomotives on the SAR. 295 of the Series 34, 34-400, 34-500 and 34-900 have been built by the General Electric Company since 1971. 208 34-200, 34-600 and 34-800 sub-series have been built by General Motors since 1971. The 34-200 series were imported from the USA with the remainder locally fabricated. Class 35 COCO. The 82-ton Class 35 series is the standard diesel-electric locomotive for 60-pound branch lines in the SAR. 200 of the 35 and 35-400 series were built by General Electric between 1972 and 1976. General Motors EMDs supplied the 150 Class 35-200s and 100 35-600 locomotives between 1974 and 1976. The first 25 were imported, the rest being locally fabricated. They have a two-stroke V8 turbocharged and after-cooled diesel engine driving a 1065 kilowatt DC generator and 6 axle hung traction motors. Class 36 Bobo. The Class 36 series was the standard diesel-electric shunting locomotive of the SAR prior to the Class 38. 124 of the 36 class was placed in service in 1975, 1978 and 1981. 100 of the 36-200 series were also built locally by General Motors and were placed in service in 1980. The 36-200 develops less power at 755 kilowatts. Class 37 COCO. The Class 37 is an upgraded version of the Class 34 General Motors version. Here, Class 37s are piloting Class 14Es on the section between Haar and Kimberley. Class 38 Bobo. 50 of these dual electro-diesel shunting locomotives were placed in service in 1993 and 1994. The 74-ton units were designed to replace any remaining steam duties, as well as bridging the gap between the 3 kV DC Class 8Es and the 36 series diesels. Components were supplied by a Siemens-led consortium and assembled at Union Carriage and Wagon. The electrical section is rated at 1500 kilowatts continuously. Class 91 narrow gauge Bobo. 20 of these locomotives, the only SAR narrow gauge diesels, were supplied by General Electric of the United States, rated at 480 kilowatts, and these locomotives weigh in at 44 tons.